The explosion itself lasted only a few seconds, but the danger stretched on for days, starting the moment the ground at Yellowstone tore open on June 13th. And that first blast was just the opening scene. Over the following week, scientists watched the Earth keep failing, collapsing inward to form a brand new boiling pool, then spouting water 30 feet into the air on its own. All of it happened just 100 meters from the closest scientific instruments ever positioned to record. An event like this, by the time we're done here, you'll understand exactly what those instruments may have captured and why it could change whether we're ever able to see one of these disasters coming before it strikes. 12 days ago, in the pre-dawn darkness of Saturday, June 13th, at roughly 5:09 a.m. Mountain Daylight Time, the monitoring equipment inside Biscuit Basin in Yellowstone National Park picked up something abnormal. This wasn't the slow, familiar background heat signature typical of a thermal basin. It was a sharp burst of seismic energy paired with infrasound, a low-frequency pressure pulse sitting below the range of human hearing. It was coming from the direction of Black Diamond Pool, a thermal spring about 2 miles northwest of Old Faithful. If you follow Yellowstone news, that name probably already rings a bell. Black Diamond Pool is infamous. On July 23, 2024, it produced one of the most dramatic hydrothermal explosions ever caught on camera anywhere in the park, hurling water, mud, and rock 400 to 600 feet into the air and destroying the boardwalk where tourists had been standing moments earlier. Biscuit Basin has stayed closed to visitors ever since. So when the instruments lit up before dawn on June 13th, the obvious first assumption was that Black Diamond Pool had blown again, but the data quickly stopped fitting that story. And that's exactly where things get interesting. The temperature sensor sitting inside the pool itself barely moved. If the pool had genuinely detonated again, that sensor should have spiked violently. Instead, it registered only a small, modest change. Something had clearly exploded, though seismic and acoustic signals left no doubt about that. But it hadn't exploded from the famous pool everyone had their eyes on. The real answer came from a camera installed at the site only the previous year, in May 2025. At 5:09:50 that morning, the camera recorded a dark plume of steam jetting upward, not from Black Diamond Pool, but from barren, entirely unremarkable ground just to the north of it. The Earth had torn open in a spot with no famous feature, no warning sign, nothing but flat thermal ground that had never done anything notable before in recorded memory. That single detail is really the thread running through this entire story. For years, all the attention at this location had been fixed on one specific pool. On June 13th, the ground opened up right next to it instead, in a place nobody had been watching closely at all. When geologists arrived, they didn't find one new hole. They found three separate sets of freshly formed vents punched into the ground just north of Black Diamond Pool, each one a brand new opening that simply hadn't existed before that morning. Large volumes of hot hydrothermal water surged out of these vents and flowed downhill into the Firehole River. By the time scientists reached the scene, most of the vents had already stopped flowing, but the northernmost one was still active, still feeding water steadily into the river. That northern vent came with a feature that tells you something important about the forces involved. It was attached to a crack running through the ground, oriented roughly north-northwest, stretching about 18.5 meters, roughly 61 feet, long. In places, this fracture gaped open as wide as 1.5 meters, about 5 feet across. Picture that for a moment. A fissure longer than a school bus, wide enough in spots to swallow a person whole, opening up in a single morning in ground that had been completely solid the day before. The water pouring out of these vents measured around 90 degrees, 195 degrees, essentially boiling point given Yellowstone's high elevation. This wasn't warm runoff seeping out gently. This was near boiling water being violently forced up out of the earth under intense pressure. Now, some important context, because I don't want to overstate what happened here. The rocks thrown out by this particular explosion only scattered a few meters from the vents, telling geologists the blast itself was relatively small, much smaller than the violent 2024 event, which hurled debris across an area of roughly 1 square kilometer. Judged purely by the size of the bang, June 13th was a fairly minor event, the kind of small hydrothermal explosion that, on its own, happens somewhere in Yellowstone roughly once a year. But you could actually see the aftermath from miles away, and not because of the blast itself. Downstream of Biscuit Basin, the Firehole River visibly changed color, turning a pale, milky gray, the unmistakable color of water loaded with fine sediment. That discoloration carried roughly 6 kilometers, about 3.7 miles downstream, drifting steadily toward the Midway Geyser Basin. That gray water is essentially a physical receipt for what happened underground, direct visible proof that the shallow plumbing system beneath Biscuit Basin had just flushed a large volume of sediment-choked water out of itself in a very short window. The ground had, in effect, emptied part of its inside straight into the river, and as it turned out, the ground wasn't finished. Here's the part of this story that genuinely has no real precedent, and it has nothing to do with how big the original explosion was. In the days following June 13th, scientists monitoring the site watched something new form that simply hadn't been there. When they first walked the ground, a brand new pool of water appeared near the middle group of vents, vigorously boiling, gray, and thick with sediment. How this pool formed is what really matters here. Most new features that suddenly appear at Yellowstone are explosion craters, holes punched outward by a blast surrounded by a ring of ejected rock and debris. This new pool was different. There was no apron of blasted out material surrounding it at all. According to the United States Geological Survey, this pool didn't form through an explosion at all. It formed through collapse. The ground itself caved inward, sinking down into the hot, pressurized zone underneath it, and the resulting depression slowly filled with boiling water. The original blast happened on June 13th. This new pool formed later, sometime between the afternoon of June 14th and the morning of June 16th. In other words, the explosion wasn't the end of the event at all. It was only the beginning of a longer process that kept quietly reorganizing the ground for days afterward. The actual measurements help make this tangible. The new pool measured roughly 6.5 Durieks, 5.3 meters, about 21.17 feet, filled with boiling water where solid ground had been standing just days earlier. And it didn't sit there quietly either. By June 18th, a week ago as of this recording, the pool had begun erupting entirely on its own, going through several multi-minute episodes of spouting, throwing boiling water 6 to 9 meters into the air, roughly 20 to 30 feet, about the height of a 2 or 3-story building in sustained bursts. There's something particularly unnerving about a feature forming through collapse rather than explosion. An explosion is a single, violent release, frightening certainly, but over within seconds. A collapse is slower, and in a way, far more revealing. It means the ground beneath the surface had been hollowed out or weakened enough that it could no longer support its own weight, so it sank days after the initial blast down into the hot zone below. In the meantime, the surface looked perfectly intact. A person could have walked right across it, and then on its own schedule, it quietly gave way into boiling water underneath. Think about the full sequence as a whole, because this is really the true anomaly. An explosion on day 1, a fracture plus 3 vents. Then, 2 to 3 days later, the ground collapses inward, giving birth to a brand new, boiling pool. Then, 5 days after that, the new pool starts spouting entirely on its own. The hazard didn't end when the bang stopped, when the system kept failing, kept shifting, kept opening new mouths in the earth for the better part of an entire week. Scientists were literally standing on ground that, days later, caved into near boiling water. And that raises the question that makes this particular event scientifically priceless, because of exactly where it happened. The single most important number in this whole story is 100 meters, roughly 328 feet. The distance between the June 13th explosion and a monitoring station the Yellowstone Volcano Observatory had installed only the previous summer in 2025. According to the USGS, no hydrothermal explosion in recorded history has ever happened this close to dedicated scientific instruments before. This is the closest range anyone has ever had on an event like this as it actually occurred. To understand why that matters so much, you need to see the contrast with 2024, when the much larger explosion tore through Biscuit Basin. Back in July of that year, there was no hydrothermal monitoring station anywhere near the site at all. The observatory's broader instrument network barely registered the event. One of the most dramatic hydrothermal blasts in the park's modern history happened, and the instruments almost completely missed it. Scientists were left studying the aftermath, working backward from scattered debris, with very little actual record of the event as it unfolded in real time. Consider what proximity actually provides. Distance blurs everything. A seismometer miles away records a smeared, faint wiggle. A seismometer just 100 meters away captures the sharp, detailed fingerprint of rock fracturing in real time. An infrasound sensor positioned right beside the vent captures the exact acoustic signature of steam breaking through the surface, not some muffled echo arriving seconds late. A camera on site doesn't merely confirm that something happened. It timestamps the plume down to the half second and shows the precise patch of ground that opened up. Now multiply that across 4 different types of instruments, all running simultaneously, all within a football field's distance of the blast, and you get something this scientific field has essentially never had before: a clean, close-range, multi-sensor recording of a hydrothermal explosion from right inside its own neighborhood. This time, the situation was completely reversed. There was a seismometer essentially next door, an infrasound sensor listening in, a temperature probe sitting in the pool, and a camera pointed directly at the ground. When the Earth opened up on June 13th, every single one of those instruments was running just 100 meters away, recording everything. For the first time, scientists may actually have a high-resolution, close-range record of exactly how one of these explosions begins. The seismic signature in the seconds beforehand, the acoustic pulse, the thermal behavior, the entire visual sequence frame by frame. That's the real windfall here. An event that has historically been almost impossible to study up close just happened in the single best instrumented spot it possibly could have. And what those instruments did or didn't capture in the moments leading up to the blast is the question everything else now. To understand why that question matters so much, you need to understand what's actually going on beneath the surface. The mechanism behind a hydrothermal explosion is, in broad outline, fairly well understood, even though predicting any single specific event remains close to impossible. Let me walk through it, because it explains both why this happens and why it's so hard to see coming. Underneath Yellowstone's thermal basins, hot water is constantly circulating through a maze of shallow cracks and channels in the rock. That water is rich in dissolved silica picked up from the surrounding rock at depth. As the water rises toward the surface and gradually cools, that silica comes out of solution and precipitates onto the walls of these underground channels, slowly building up a hard, glassy mineral coating over time. And here's the trap. That silica coating is essentially impermeable. As it thickens, it can seal off an entire pathway, effectively capping a channel that had previously been venting heat and pressure safely up to the surface. Once a conduit gets sealed this way, the hot water and steam trapped beneath it have nowhere left to go. And cause pressure builds, temperature climbs. You end up with superheated water held under intense pressure, trapped beneath a layer of rock and mineral seal, essentially a natural pressure cooker buried just a few feet beneath ground that people walk across every single day. And it stays stable, looking completely ordinary from the surface, right up until the moment the confining rocks simply can't hold anymore. When that seal finally fails, pressure drops instantly. The superheated water flashes explosively into steam. That steam expands with enormous force, and the ground above either blows outward violently or, as we saw in the days following June 13th, destabilizes and collapses inward instead. Now connect that mechanism back to the instruments sitting 100 meters away. The single most valuable thing they could possibly have captured is a precursor, some small signal in the minutes or hours before the blast, indicating that the underground seal was about to fail. A slow creep in temperature, a subtle shift in the infrasound reading, a flicker of tiny micro-earthquakes as the rock began to crack apart. If that kind of signal genuinely shows up in the data, the observatory may have its very first real foothold on forecasting these events. A way to say, even just minutes ahead of time, that a specific patch of ground is about to give way. But there's also a darker possibility, and scientists are being honest about it. The 2024 explosion gave essentially no clear warning beforehand. If this new, close-range data set also shows nothing, if the ground stayed completely quiet right up, until the moment it exploded, then the most unsettling version of this hazard gets confirmed instead. It would mean these explosions can genuinely strike out of apparent calm, with no detectable precursor at all, in terrain where millions of people walk every summer. Either answer here is enormous, and this is genuinely the first time we've ever had the actual data available to even ask this question properly. Which brings us to why this exact spot has been so restless for so long. June 13th didn't come out of nowhere. It's the latest chapter in a story that's been quietly unfolding at this precise location for nearly 2 years now. And the previous chapter is the reason any of us know the name Black Diamond Pool in the first place. Rewind to July 23rd, 2024. Just before 10 in the morning, with tourists standing right on the boardwalk, Black Diamond Pool exploded. A plume of mud, rock, and scalding water shot 400 to 600 feet straight up into the sky. Debris rained down across an area of roughly 1 square kilometer. The boardwalk was torn apart, and visitors ran for their lives. The entire event lasted about 55 seconds, and by something close to a miracle, nobody was hurt. It's worth being clear about exactly what that event was and wasn't. It was not the supervolcano stirring. It was not magma on the move. It was purely a shallow hydrothermal explosion. The exact same pressure cooker mechanism, the same near-surface steam buildup, just on a far larger scale than what we've seen this month. But the truly important part is what happened afterward. The basin closed for the remainder of the 2024 season and has remained closed ever since. And in the time since that first blast, Black Diamond Pool hasn't stayed quiet. It has erupted repeatedly. There was an eruption in May 2025. There was a muddy eruption in December 2025. Most of these events went essentially unwitnessed, simply because the area had already been closed to the public, but the instruments and the occasional trained observer kept quietly noting them. It's worth pausing on what that ongoing closure represents, because it's easy to skim past. an entire basin inside the most famous national park in the United States, a place that, before 2024, drew steady streams of visitors along its boardwalks, has now been fenced off from the public for nearly 2 straight years. That's not a precaution anyone takes lightly. It's the National Park Service acknowledging, in the most concrete way it possibly can, that the ground there simply isn't safe to stand on, and hasn't become any safer with the passage of time. Every smaller eruption since the original blast has only reinforced that judgment. Step back and look at the overall pattern. A major explosion in 2024, a string of smaller eruptions running through 2025, and now, in June 2026, a fresh explosion tears open new ground right beside the pool, followed by days of collapse and a brand new spouting feature. That's not a system that blew once and then quietly settled down. That's a shallow underground plumbing network that has been actively reorganizing itself for almost 2 full years, finding new weak points, opening new pathways, and stubbornly refusing to return to any kind of stable equilibrium. The 2024 blast, in hindsight, reads less like a one-off accident, and more like the opening act of an unstable period we're still living through right now. June 13th is simply what it looks like while that system is still actively failing. And that's exactly why the online reaction to all of this gets the actual danger so badly wrong. Every time Yellowstone does something even slightly unusual, the same predictable wave of claims floods across the internet within hours. The supervolcano is waking up. The government is hiding an imminent super eruption. New vents and rising steam are supposedly the final warning signs before some continent-ending blast. I want to take that seriously enough to address it directly, because the truth here is both more reassuring and, in a strange way, more genuinely interesting than the myth. The data flatly contradicts the super eruption story and does so quite clearly. Yellowstone's volcano alert level remains at normal. The aviation color code remains green. Throughout May, the entire park recorded only 45 small earthquakes total, the largest measuring just magnitude 2.0. A tremor you wouldn't even feel if you were standing directly on top of it. There were no earthquake swarms. There was no significant ground deformation detected anywhere. There was no signal anywhere in the broader magmatic system suggesting magma is actually rising toward the surface. A hydrothermal explosion like the one on June 13th is a shallow local steam event driven by groundwater, and pressure just a few feet down, not by magma pushing upward. It is absolutely not a precursor to any kind of caldera-scale eruption. On the specific question of the supervolcano, the underlying science is genuinely calm and reassuring. But here's the part the doomsayers online consistently get backwards, and it's genuinely worth sitting with. There is a real hazard at Yellowstone. It's just not the one you see in disaster movies. The honest danger here isn't lava. It's exactly what we've been describing throughout this whole story. A thin, sealed crust of superheated ground holding back near boiling water in places where tourists casually walk every summer, and which can give way with little or no warning at all. In 2024, it destroyed a boardwalk full of people just moments after they managed to flee. The fear driving all the supervolcano panic online is real fear. It's just aimed at entirely the wrong target. People are scared of a magma chamber sitting miles underground, when the thing that could actually hurt someone is the ground directly beneath their own feet. To keep this properly in proportion, it helps to know roughly how often the Earth here does this kind of thing. Small hydrothermal explosions, like the one on June 13th, aren't especially rare. Something on this scale happens somewhere in Yellowstone roughly once a year. Larger events become progressively rarer as they get bigger. A pork-chop geyser-scale explosion similar to the one back in 1989, which left behind a debris apron about 15 feet across, still visible today, comes along roughly every several years. An explosion large enough to leave behind a sizable crater happens, on the order of once every few centuries. And the truly massive events, larger than 10 acres across, occur perhaps once every several thousand years. For a sense of scale, the largest hydrothermal explosion crater on Earth sits along the north edge of Yellowstone Lake, a feature called Mary Bay, about 1.5 miles across, blasted out roughly 13,800 years ago. So an event like this month's, measured purely by raw size, sits comfortably at the small and relatively frequent end of a very long historical scale. What isn't routine here, what genuinely makes June 13th worth all this attention, is the combination of 2 specific factors. It's the closest any hydrothermal explosion has ever occurred to dedicated scientific instruments, and it's the very first time scientists have watched on camera a brand new pool form through collapse, and then begin spouting entirely on its own in the days that followed. That's the genuine first here, not the explosion itself, but the detailed record of it, and the slow-motion failure that followed in its wake. So here's what to actually keep an eye on going forward. The Yellowstone Volcano. Observatory now holds a data set unlike anything it has ever had access to before, and the central question hanging over all of it is whether anything in that close-range recording shows a genuine precursor to the blast. If it does, expect to hear about a real, meaningful step forward in our ability to forecast events like this. If it doesn't, expect scientists to say so plainly and honestly, and expect Biscuit Basin to remain closed, because the lesson in that case would be that this particular ground can fail with no advance notice whatsoever. Keep an eye on the new collapse pool, too. Whether it keeps spouting, stabilizes into something calmer, or continues growing will tell us whether this underground system is still actively reorganizing itself, or finally starting to settle down. The supervolcano is not waking up. The data could not be clearer on that point. But the ground inside Yellowstone's thermal basins has just demonstrated in unprecedented detail that it can tear open, collapse inward, and boil over for days at a stretch. And the most realistic danger inside America's first national park isn't buried miles underground at all. It's hiding quietly just a few feet beneath the ground people are standing on right now.